So, if we talk a little bit about these concepts of energy and then tie it in with glow sticks, and then I'm going to turn off the lights and we're going to see how well we can see these glow sticks glow and tie these ideas together. Okay, so in terms of how light energy is relevant here, we have a few different types of things that can happen with light. And the first one is absorption of light. And this also ties in with what's called the photoelectric effect. This is what Einstein got the Nobel Prize for. He did not get the Nobel Prize for relativity. All right, so he got this idea when people were trying to figure out, it was actually right around the time of the ultraviolet catastrophe that I talked about earlier. And so what ultimately was discovered by Einstein was that absorption of one photon by one electron is possible. So in other words, there's a 1-to-1 ratio of photons to electrons. So when you have an electron in a molecule, all molecules have electrons, and so they can absorb energy, and they can absorb light energy. There's different kinds of energy they can absorb, and one of them is light. So let's imagine we've got two energy levels. So I'll call this lower one energy level 1 and the higher energy level 2. And let's say we have an electron that's down here. Okay. And then let's imagine, so this will be like a different moment in time, okay, same energy levels, that this electron is hit by a photon. And that photon of light, which has some amount of energy that is equal to Planck's constant times the frequency of that energy. But this is our symbol for a photon. Okay, so let me write that here. That this photon that has this exact amount of energy causes a transition or an excitement of that electron and causes it to get excited up into this higher energy state. So look at this. In terms of this whole concept of conservation of energy, we've got light energy being converted into this potential energy, right, of the electron. It was at a lower energy state and it went to an upper energy state. Okay, you could also call this chemical potential energy because chemical potential energy has to do with the relative positions of electrons. Their positions relative to other electrons, relative to the nucleus in this case. So, okay, so here is an example of absorption. Okay, we also, with light energy, we can have emission. And here it is the exact same thing in that we've got a 1-to-1 ratio from when you have an electron and, I want to move this up, okay. So with emission, you start out with an electron being excited in a higher energy level. We can call that energy 2, higher energy, versus this lower energy level. And now assuming that this is an excited state, and so there is space for that electron to then drop down, back down to the ground state, where it's more stable, okay? When that happens, and so let's draw that in our next scenario, when that electron drops back down from this higher potential energy state to this lower potential energy state, it is losing energy when that happens. And so it is losing energy in this example here in the form of a photon. Okay, so here I am defining that the topic that I'm showing you is emission, and this is emission of light. Okay. That isn't to say that there maybe are other ways that this electron could lose energy when it drops from being up here down to here. But one way is by losing a photon. Okay, so this electron drops down, energy, the photon comes out, and by definition, the energy of this photon equals the difference in energy between energy level 2 and energy level 1. Okay, so these usually go hand in hand because you have an electron, it gets hit by a photon, absorbs it, it's excited, and then it immediately can drop back down and it can then emit that same frequency of light. Okay. So, how do glow sticks work then? If in a glow stick, all you're doing, and I have some glow sticks right here, if all you're doing is breaking it, then you know how you take it here. I'll show you here. Okay, with a glow stick, it starts out with just the stick, and you see this goopy stuff inside, right? Okay, and so yes, the lights are on in this room, so you could say, oh, the lights from my the photons from the lights in this room are exciting those molecules and then making them glow. By the way, right now this isn't glowing, so if I turn off the lights, which I'm going to do, it's pretty dark in here now. It's not totally dark because I still have one light, but I am going to switch this light off. Okay. So right now, I feel like I have a little bit too much light in here. That's okay. Oh, I guess that light, yeah, that's okay. So we want to see a little bit, right? Right now, this is not glowing, all right? And right now, all the lights, believe it or not, all the lights are off in my room. But we've got some chemicals in here, okay? And so the electrons have not gotten excited yet, but there are other ways to excite these electrons besides hitting them with photons. And one of the ways is chemically. So there are chemical reactions where when you mix things together, it causes the electrons to get excited. And then after they're excited, they can then drop back down and they can release light. They can release photons. Okay? So in glow sticks, they separate out those chemicals from each other, but then when you break it, you can hear it snap, snap, snap. Crack, 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 crack. Okay? You are then causing the chemical reaction to begin, which then allows this to happen. Now, notice how it's glowing in some of these places and it's not glowing in the other. And that's why a lot of people, they shake them because you're essentially shaking up those chemicals so that they can mix. Ooh, they can mix better. Okay, so now it's glowing a bit better. Look at that. So you can really see the light emission that's happening here. Okay, so here we have fluorescence occurring. These electrons are excited, and then they drop back down, and then they glow, and it's so beautiful. There's just something about fluorescence and also phosphorescence that is so magical about how it looks. It's also true for bioluminescence, like fireflies and glowworms, and there's also these dinoflagellates that are these tiny single-celled creatures that they undergo bioluminescence when there's changes in pressure in the water. And so there are places where you can go kayaking, like in Puerto Rico and other locales, where you can essentially, you are swimming amongst, well, you're paddling because you're in a kayak, amongst these beautiful glowing creatures in the water. It's really, really amazing. So, okay, so here's a yellow one. Breaking it up. So you can hear snap, snap, snap. So we started the chemical reaction, right? It's starting to emit light. And I'm going to shake it. Yeah, mixed it up. Okay, so that's emitting light. Let's look at this one. And again, I want to have a comparison. So that one is kind of like a reddish one. No, it's different. How many different colors are there? Okay. Yeah, these are the same. Okay, so this one, I'm going to have one of them. I'm just going to let it stay not glowing. And then I'll break this one. And so we'll have a comparison. Okay. So here, I'm going to snap it. So here's all the... Yeah, the green is a lot shinier than the blue. Let's see if we can watch it disperse. Yeah, it is spreading out, huh? Ha! Look at that. Yeah, so there's our red. Here's what the red looks like, not emitting. Yeah, the red is shinier than the green, isn't it? Isn't that cool? I don't know what this one is. Let's see what this one... Oh, this is the blue. Oh, see, this is what the blue looked like before. It was just very pale, I think. Or, I don't know. Maybe that one's purple. Oh, I think this is different. This is amazing. I've never done all the different colors in this.